So welcome back to the channel. This little video is going to be on battery consumption of the MTR105. I'm just doing this more out of my own little personal interest really. Now in order to do this I have here a source measurement unit. I have my 3 meters obviously, and all I'm going to do is set this up to the relevant voltage and record the power used by the instruments for certain functions. All I do is power each meter from the source measurement unit. To do that, depending on the battery setup of what I need, I've got some dummy cells here and I've made up some little adapters that give me a contact point and a wire feeding to it so I can plug in and then just put that into replacement of the batteries and then feed the instrument that way with both of these. Now what I will say is this MTR105 is quite battery hungry. This little lot here, that's 3 sets of batteries. It's on its 4th set of batteries now in the space of around about 8 months of usage. It's not been particularly heavy usage at times. Whilst I've been doing all these tests, yeah, it's been doing a fair bit of work, but at other times it hasn't been doing much work at all. Obviously with the instrument having quite a considerably extended capability in comparison to the other two, that's quite a few more tests. In fairness to Megger, they do make a charger to go with the MTR105. I believe it's the same charger that's used in the top end of their MIT 420 series. Costs around about £70–80 in the UK, but I don't believe you get the battery pack for that. I think you have to go out and get your own batteries. It's just that the head plugs into the top here to allow you to charge the batteries within the instrument. If you do want to go down this route with the MTR105, I would strongly recommend that you go to rechargeables. Obviously you don't have to have the Megger charger, you can just buy a standard charger and just keep swapping batteries in and out if you want to. But I would imagine if you do a lot of motor testing, you're going to need a lot of AAs. Okay, so what I plan to do is run the instruments through a number of tests. Obviously the instruments aren't identical, therefore what I'll do is a test for each function and I'll stick that data up at the end. But what I'll also is comment out and do a separate table with the functions that are comparable across all 3 instruments, and then you get a better idea of what the kind of consumption is for each of the instruments and in comparison to one another. Okay, so we'll set up some tests. I'll do the MTR105 first. Okay, so we are set up with the MTR105. I'm reading the mains voltage from the adapter on here, so we're displaying 244 volts, and this is the dimmest setting for the light, and we are on 1.25 watts. Let's go up. Setting 1 is 1.34. Setting 2 is 1.5-ish. Bounces around a fair bit. 1.61 for setting 3. And 1.74 for setting 4, which is the brightest it can go to, then goes back down to dim mode there. Okay, so for the next test we'll flip him around to 500 volts insulation resistance test. Off camera it's plugged into 500 kilo ohm load, so it should be a 1 milliamp current being drawn, and we are, without a test going on, we're on 1.19, 1.2 watts. We'll just go on for a time, so he's on, and go on, and we jump up to 2.7 to 2.71 watts, and then you can see we're drawing just over 1.01 milliamps. So we've not got a brilliantly efficient insulation resistance setting there. It's just, that's on its dimmest setting, so on its dimmest setting we draw 0.96, 0.98 watts, and we'll flick him on again, and it goes up to 2.4, 2.5 watts, so that's nearly 1.4, 1.5 watts for the insulation test function. It's quite high compared to a lot of the other instruments I've tested. We are on 100 ohms, 2-wire resistance, and we draw 101 ohms and 1.47, 1.49, 1.5 watts. That's on 20 milliamp, and obviously we can pump up to 200 milliamp and do the test, and it jumps up quite considerably, 2.5 watts then. Okay, so we'll plug that and we'll flip him down to 100 milliohms, and we'll put the speaker on. So 1.3, 1, start the test with the speaker on, plus 205 milliamps, 2.9, 3 watts, pop it down to 20 milliamps, and drop down to 1.9, 1.8. Yeah, she's definitely battery hungry, this one. Let's flip him round to done volts, done insulation test. I'll do 4-wire. So I'll use the same decade box. We'll put him on to put him on 20 milliohms. I need to pop on the connection. And it's found the connection. That's not really changed anything on it. We dropped that down, or we're on brighter light, weren't we? You can read it on that just. So let's try it on its minimum light. We're 0.9, 0.92, 0.93, 0.96. Let's go for a test. It was 2.4, 2.5 watts, and drops down to a watt. So yeah, that's because the screen's come up a little bit brighter again. But about 1 watt, jumping up to 2.5 watts while it's actually doing a 4-wire test. Flip into diode test. When he finds his diode, oh, there he is. So we'll do forward. So turn the leads out of the way. So we are on just above a watt, and we'll go forward bias on the diode. 7.1, jumps up to 1.4, 0.5 watts with full diode forward voltage test. So that's the test done on that. As I said at the beginning, I've done a lot more tests. I'll stick them all in a table at the end. I'll move on to the U1461A now and do some tests on that one. Okay, so we are set up feeding the power into the Keysight U1461A. At the moment the light is dimmed, and you can see we're circa 0.135 watts on there. We'll turn the light on, and then you can see we jump up to 0.17, dancing around a bit. The light on this only has one setting on the Keysight, and you can see I've done both the tests whilst measuring the mains voltage. Okay, so we'll just unplug him from the mains, and we'll do a resistance measurement. So that should be 100 ohms there. So sitting in between the two voltages, obviously we're on maximum light, and it's 0.14, 0.15 watts. 100 ohms. I'll switch into continuity, will be the noisiest one, and we'll switch him down. And there you see, fairly efficient, and it goes up about 0.03 watts. That's enough of that. So we'll fling him round to insulation test at 500 volts. And that's with nothing going. We're 0.14, 0.15 watts. And we'll just flip on to time, and we'll switch it on. And you see just under 1 watt, 0.97, 0.96. Flicks up to 1 watt every now and again, but it's 0.98, 0.97 for a 1 milliamp insulation test at 500 volts. I'll move on to a similar set of tests for the MetraHit coil. Okay, set up with our MetraHit coil. You can quite clearly see 0.05, 0.08 watts. Seems to be quite a bit more steadier as well than the other two instruments. We're reading our 238 volts. It's picking up off the mains. We'll turn the 0.050, 0.051 watts. Turn the light on, because goes up to 0.128 watts. So yeah, quite a powerful backlight you've got on that. Okay, so that's the AC voltage measurement. We'll unplug him and we'll flip him round to ohms. Turn our light off. This will be our 100 ohm reading. There's 100 ohms and it's 0.050 watts. So the continuity buzzer is a different setting on the function switch on this one. Let's just unplug him and 100 milliohms, plug him in, and 0.115 watts for continuity buzzer, 0.061 with the open circuit. Okay, we'll flip him round to insulation test, plug him into our 500 kilo ohm load, and 0.13 watts just sitting here. We start the test. Short 0.657. It's a bit of a grumpy insulation tester, this is. So we are 0.497 now. And 1.19 watts, but something the power supply doesn't like, because you actually observe the battery symbol is dropping down, which it shouldn't be doing. So I'm not sure what's happening with that there. It's constant on 3 volts. So that's the testing completed for the battery consumption. I'll put the results up so you can take a look at them for yourselves. Obviously the MetraHit, its type of display, means it draws less consumption than either of the other 2 instruments. The full colour display of the MTR105 is a real battery hungry thing. Probably knew that before I started the tests really. But if I'm going to score them based on battery capability, it's 5 points first place to the MetraHit, and then the Keysight is second place, with the MTR105 coming up in 3rd place. Okay, so that's it for this video. Thanks for watching. I'll see you in the next video. It should be a summary of the testing carried out on the 3 instruments.